Okay, so in this class we are going to discuss some more question based on definite integrals from miscellaneous exercise. So let us see this question number 35 from miscellaneous exercise NCRT. So it is 0 to 1 x dx dx. So you will do it by integration by parts. Treat this as second function, this as first function. Apply integration by parts. First as it is integration of second. 1 minus first का derivative, x का derivative is 1, ex dx. After that, integration of ex is ex. Now, simply substitute the limit. So when you put the limit, this will become so what do you get? So now you can solve it further. So e to power 1, e to power 1 will cancel out. So you will left with only e to power 0 and that will be equal to 1. So we want to prove that this definite integral should be equal to 1. Now after this, let me do question number 37. So in question number 37, it is 0 to 90 sine cube x dx. Now you can see this question, it is that odd power of sine. So you know how to settle this odd power of sine and cos. So let us rewrite the question in this form. This is what we can write. Now this sine square x can also be written as 1 minus cos square x dx, sin x dx. This is what we can write. Now obviously you have to put cos x is equal to t. So we will put cos x is equal to t. So now when you put cos x is equal to t, you will differentiate both the side. It is minus sin x dx that is equal to dt. So that means sin x dx can be written as minus dt. Now let us change the limits also as per our substitution. So this is our substitution. So you will say when your x was 0. When your x is 0, so cos 0 is 1. So your t will become 1. Cos 0 equal to t, so t is equal to 1. When your x is 90, then we know that cos 90 is 0. So these are the new limits. Now let us convert this question totally in terms of t. So we are going to convert this question totally in terms of t. So we can rewrite this as I can be written as minus 1 to 0, 1 minus t square dt. So this can be rewritten as minus 1 to 0 dt plus 1 to 0 t square dt. Let us integrate them separately and then we will substitute the limits. So when you integrate this, it will become minus t. Limits are running from 1 to 0. This will become t to the power 3 upon 3. Limits are running from 1 to 0. Let us substitute. So 0 minus 1 plus 1 by 3. This can be written as 0 minus 1. So in place of t, I am putting 0 and I am putting 1. So upper minus lower. Upper limit minus lower limit. So finally, you will get this as 1 plus 1 by 3. So when you do calculation, it will become 4 by 3. Okay, it is minus over here. So you can see that when you do calculation, this will become 2 by 3. And this is what we want to do. So this is the complete solution for question number 37. So next we are going to start with question number 38 from miscellaneous. So we want to integrate this expression to tan cube x dx. We want to prove that this should be equal to 1 minus log 2. So in order to integrate this integral, we can rewrite this as 0 to 45. 2 can be taken out. This can be written as tan square x into tan x because it is tan to the power 3. So obviously we can rewrite this in this form. Now you know that tan square x can be written as sec square x minus 1 into tan x dx. Let us detach this integral into two parts, 0 to 45 sec square x dx into tan x minus tan x dx. So this is how we can write it. Now after this, you have to integrate these two integrals separately. Now first one can be done by substitution method and second integral is a direct formula. So I can write this tan cube as tan square x into tan x. After that, this tan square x can be written as sec square x minus 1. Multiply this tan x, this is what you will get. Now, in order to integrate this one, for the first one, you will take tan x is equal to t. So you know that its derivative is sec square x dx, that will become dt. So now your integral will become tan 0 is 0 and tan 45 is 1. And this will become dt. So I had changed the limits also. How to change the limits? You have to use the substitution. When your x is 0, then tan 0 is 0. That is why I had written 0. When your x is 45, tan 45 is simply 1. So your new limits are 0 to 1. It will become t dt. Now, I can rewrite this. I can write the second integral as 2 outside. So tan x, this was log sec x. So I can write this as log sec x. Limits are running from 0 to 45. So substitution is applicable only for the first integral. We are not applying the substitution for the second integral. So here the limits will remain unchanged. So just I had written this as 0 to 45. Tan x, formula for integration of tan x was log sec x. Now after this, just integrate this one and then it's a matter of substitution of limits. So this can be written as 2 e square upon 2. Limits are running from 0 to 1. And this will be 2 log sec 45. So you know that sec 45 is root 2. And next one will become 0. Why? Because you know that sec 0 is 1 and log 1 is 0. Let me write the complete steps. This will be log sec 0. So in the next step, I can rewrite this as 2 log minus log 1. So this can be written as 0. So by using property of log, I can use that third property of log and I can write this as 2 to the power 1 by 2. This 2 can be taken out, so it will become 2 upon 2 log 2. So finally you will get 1 minus. So this is what we want to prove here also. This is how we can do question number 38 from miscellaneous.